This is Breaking Down Security, and I'm Brian Brake. Welcome back, listener. This is Brian and the esteemed Mr. Betcher for Breaking Down Security.
Hello.
Hello, Mr. Betcher. So, let's get right on into our interview today. I know that we're only 2 weeks away from DerbyCon, and we can talk about that next week. But this week, it's really early my time because the gentleman that we're interviewing is really late in the future. He's like 12 hours into the future. So he is Shriraj Shah. I got that right?
Yeah, perfect.
Oh, awesome. And he is an expert. We're going to talk about HTML5 and Flash this week, which is it's pretty contentious depending on which camp you're in. If you're Adobe, of course, you want to keep your intellectual property out there into the mainstream and be as important as you possibly can. But of course, as many of us in the infosec industry know, that Flash is not as secure as it could be, and that's because it's an application made up of code made by developers who make mistakes, who mean well, but obviously come up against hurdles with time and those kinds of things. So, what we wanted to have Mr. Shah on this week for is to discuss HTML5 because everybody thinks that it's going to be solving all of our problems and help us get rid of Flash, which is a great, awful, awful thing. And we wanted to maybe, cast a new light onto HTML5 and show that it's not going to really solve a lot of problems and might actually introduce new ones. So welcome, Mr. Shah, to Breaking Down Security.
Thank you very much for inviting me. It's HTML5 is an interesting field. A lot of research is going on, and let's see how we can secure now HTML5 stack.
I appreciate that. So before we get into our questions, let's get some background about you. What's most of us infosec people have an origin story. I would like to find out what your background's like and where you came from and your roots.
Pretty much like I'm running a company called Blue Infi Solutions. We are based in India here, but before starting the company, I used to be in US. Did my master's there, and then I used to work with Chase Bank Foundstone, where I started my career in application security. So that's where we started looking into web hacking. So I wrote a book with Stewart and Sawmill on web hacking. Then pretty much we engaged in writing some scanners for web applications. And 2007 onwards, just focusing on Blue Infi and doing all application security stuff. So we are a small consulting firm providing penetration testing, mobile security testing, architecture reviews for all sorts of different sorts of web application. And pretty much in 2007 onwards, where we are started to see this web technologies changing rapidly from traditional to Web 2.0 and then Ajax and then HTML5 and so on. So I primarily focus on writing some code, writing some tools on HTML5 and doing some research how things are going on. And in between, I wrote a couple of books on web services hacking and Web 2.0 hacking. So that's pretty much my background as far as application security is concerned.
Very nice.
Mm-hmm.
Okay, so maybe you could give us a little history about why HTML5 is coming about. When I was coding web pages 401, HTML 401 was like the new hotness. Everybody was like, embrace style sheets and, get rid of take the presentation layer out of the HTML. It should just be a way to render the page. When I built web pages back in 2001, oh my God.
Right.
It was, bold tags and, the blinky tag and all that. And then it was like, okay, that all needs to go into the style sheet. And HTML5 takes that even further, right? With additional presentation functions and I keep hearing about the canvas tag a lot, which
right.
And
yeah,
like,
so Yeah, pretty much like if you look at the background, so HTML1 is around 92, where we have HTTP and HTML1 started with those links type of browsers, and then we have come to HTML2 and HTML3. That's where HTML3 is where all uh, different dynamic components have started to kick in, like Java, JavaScript, we have XML, and actually a DOM or a document object model, which was presented around HTML3 time. Till HTML3 and HTML4, the focus was on a presentation layer. So as you said, people were more focusing on CSS. The event model of a DOM was dynamic changes into the images and so on. So there was no powerful APIs for powerful background or a backend connection and so on. So still Web HTML4, if you look at the standards, it's all CSS driven. But one of the component which was added around 2000, around HTML4 was Ajax. So we have this XML HTTP request object and things were added. So some power on the JavaScript had started to come in, but nobody was using Ajax till 2005 or 6, around the time when Google came with something called Suggest Now. So while you are typing, a backend call will go and grab, like as soon as you type A, you will get the list of pop down where you say something starting from A and so on. So 2006 or 7, where we have a canvas, SVG, everything, all presentation layer was very powerful. But evolution started for HTML5 is around that 2007-8 time, where we have a drag and drop API, protocol handlers, web workers, CSS, 2D, 3D, input types, different input types has started to come in, web workers, HTML5, XML HTTP request object was changed from 1 to 2, touch events, WebGL, and file API and whatnot. So Web SQL. So that's where things are spiced up. And by 2012, what we have is very rich standards already baked into all the browsers, be it a Chrome, Firefox, depending on versions, into all these browsers. So what has happened is, on a time axis, if you look at, we have a lot of new features coming in, but at the same time, on the browser technology complexity, we have new features which are added, which are all HTML5 driven. So that's how HTML5 has evolved. And as it started to evolve, what have happened is another two competing technologies like a Flash and a Silverlight, both were there. And rapidly HTML5 started to take over with a lot of different excellent libraries on a client side as well, like Angular JS and so on. So what have happened, Dojo and so on. So what have happened is people have started to migrate out from a Flash and a Silverlight, not specifically from the security purpose or security, like if your Flash is coming up with a lot of securities or Silverlight has some securities. That was not the focus, but the focus is whenever you have a native application, you don't have to worry about whether the Flash is enabled on the client or not, and so on. And all different browsers are started to support it. So pretty much like Apple, Google, Microsoft joined together and come up with these HTML5 specs, and still a lot of different specs are coming out. Now what we have is an HTML5 specs which are coming to bake in IoTs as well. So now you have HTML5 specs for different Internet of Things as well. So that way, pretty much like HTML5 evolved long way now from 2007 to 2015. So good 6-7 years have passed for HTML5.
So it's very appealing to developers because it's so platform independent. Is that what I'm getting?
Yeah, it is pretty much a flat platform independent. You don't have to worry about the client side support. It's like someone opens a browser, everything is right there. You don't have to worry about which Silverlight version they are running with, which Flash version they are running with, and so on. Mm-hmm. So that is one. The second is definitely a JavaScript. So everything you're writing in a JavaScript, which is like kind of a universal language for all the browsers as well. So that is also appealing for the developers to write things in a native code. So you can create things in a JavaScript. And then on top of it, to support the browsers, as well as we are not talking about just the browsers on the desktop. Now we are talking about the browsers and the components which are getting loaded in your mobile devices as well. So be it Android or iOS or your iPad or so on. They can also load the same HTML5 content which your desktop is loading. So pretty much it has become a more universal platform, independent technology rather than a plugin centric technology.
So with Google and Microsoft and all these companies getting together and agreeing on these ideas, all the browsers that each of those companies make must fully incorporate all the HTML5 standards, right?
Yeah, they have implemented pretty much a lot of them, but then there are few like say for example WebSocket. So there were some confusion about which browser has implemented, which browser has not implemented, and so on. So most of them right now, if you say all these different features are already implemented by browser, but like you can there is a whole matrix out there which says that which version of which, say for example WebSQL, then which browsers supports it, from which version onwards they are supporting it, and so on. But like most of the common features, if you say like a local storage or web messaging or WebSQL, they are now supported cut across.
Okay, so you said web messaging. What could you maybe explain a little bit about what that is?
So they have in HTML5 there is an API for web messaging. So say for example, when we have say for example you have a browser and you open HTML page. Now you create two iframes in HTML page, right? Now there is no messaging mechanism out there by which you can allow two iframe to talk with one another. So what you need to do is, if two different iframes wants to talk with one another, what you need to do is you need to create some server-side pipe and then connect both of them. So now what we have is a web messaging API which is bundled into the browsers, which allows you to do cross-thread communication. Like you have a one thread running in a one iframe, which is keep on listening and sending messaging to the server and so on. So there is powerful API which is out there which allows a web messaging mechanism. So it's like a kind of a, you can say it's like a multi-threaded things where in the browser you can create a web workers and web messaging, which allows you to do multi-threaded things, and which allows you to do a back-end connection talking with the front-end connection and so on.
So it's like a secure tunnel between your web and your data. Is that it, or is it? You mentioned iframes. So does it call another site more securely than it used to?
It's not. From the security standpoint. It is a messaging is a more from the synchronous and asynchronous way of communicating between the threads which are running in your browser. So it has nothing much to do with the security. Say, for example, the security angle would come like, say, for example, you are already loaded pages on SSL. The message is anyway going to go on the tunnel on which you are working. So that is not the point. But the point is, like, you have a a method by which you can gracefully talk with your own application via JavaScript components.
Wow, that's powerful. It's like a built-in mailbox almost between threads,
right? Exactly. So that's where a lot of different applications which are using web messaging. So, for example, exactly as you said, like you are working on a web page where you have a small widget sitting, which is your mailing widget, and then you have that particular widget is like constantly making a JavaScript calls. Using a web messaging is just listening that any new message has come or not. So you don't have to refresh and reload the page and so on. So it's like a little messaging mechanism which you can utilize across.
Okay, so there's a lot of cool features with HTML5 built in already for development, and it seems like it's really easy.
A lot of features. There are like you have a very powerful canvas on which you can support bitmaps and so visual images, game graphics, etc. the powerful tags which you have for multimedia, like a video tag and audio tag, which are built in with codec and so on. So you don't have to worry about which player they have on the browser or which plugin they have. Now you have HTML5 storage, which is a very powerful way of, you can just local storage. You can put content in your DOM, in your local page. You have web workers, which are which can run in a background process. Like you now, all of a sudden, what you have is your browser is now multi-threaded. So you can load a JavaScript where you are starting 5-6 different web workers threads, which are listening to connections, listening to somewhere like 7-8 sites at a time. You are just listening, or tunnels you are creating, so the new content can ship in. A lot of support you have for offline application, right? Like you have a application layer cache, so you can do offline browsing as well. So Google offline support is now available, which allows you to dump your mails on your app cache or offline viewing or so on. You have a geolocation pretty much from the browser or from a GPS, you can, or a wireless connection, you can find the positioning. One of the most powerful features on top of it is you have a web forms and inputs. So now you have a lot of different data types for web forms, like UML, email, URL, time, placeholders, autofocus, sliders, pin box, speakers, etc. So all these different inputs which you need to create through libraries, now they are just baked into your browser. There are history APIs, very rich history APIs out there, which can manage your browsing seamless. And then very powerful thing, which is right there in HTML5 is a WebSocket. So you can create a TCP duplex connection using WebSocket API. So pretty much the new URL schema is there, WS colon and WSS colon. You can, the gaming APIs or gaming systems would be using that. You have file system APIs and so on. So there are plenty of things which are added natively, and all these different things are in a way a spec. So there are specs for each of these, or maybe a group of specs created for each of this, and it's all there. So HTML5 is very powerful in that sense.
Now, with all these new features, I just think of it as a hacker playground, right? With all the new stuff that's added, and has it even been vetted? Now, with the fall of Flash and Silverlight comes the rise of HTML5, and a lot of people are touting it as the be-all end-all because let's get rid of Flash because it's got all these problems. But are we introducing an attack vector that's even bigger than what Flash can offer?
There is fundamentally, if you look at the Flash, the vulnerabilities which were coming are more from the Flash player itself. So pretty much when you look at the HTML5, the HTML5 specs are not going to create a vulnerability, maybe not going to create a vulnerability on its own. But the way these components are going to be used by developers, the way they are going to get coded in a JavaScript and so on, and then there are possibilities of leveraging some of the specs which are not insecure by nature, but they are designed for better communication or better features. Those can be definitely get leveraged by attackers or by hackers. In the sense. So in a way, I think if we are comparing HTML5 with the Flash, then it's not apple to apple comparison from the security standpoint, because Flash is more like a plugin on which the code loaded, and HTML5 is a more native code which browser itself loads. So in the HTML5 area, the emphasis is more on the secure coding. In the Flash arena, what we had is more like a Flash itself has to be secure, like a new version of Flash has to be loaded because the previous version was vulnerable and so on. So that's the fundamental difference between HTML5 and a Flash, I would say.
So we're taking the responsibility from the Flash developer and putting it on the everyday application, whatever website developer, right?
Yeah, exactly. In a way, yes, we are just putting responsibility on the developers of HTML5 based application and so on. And HTML5, if you look at with the Web 2.0 and Ajax, it is more from the architecture standpoint. It is more browser components we are talking about. But when we have the browser components and browser architecture changes, there is a symmetrical change happens on the server side as well. So now what have happened is we have more API driven or web services driven technologies running on the background. Uh, and then we have a JSON or XML streams, which are going back and forth between HTML5 in your browser and then server-side components which are maybe written in .NET or Java and so on. So it's a combination of server-side and a client-side technology when we really talk about HTML5. Just plain HTML5, we focus is more like become more just the client-side technologies as such. But from the architecture standpoint, when we look at the HTML5 applications, when it comes for the reviews, we look at as a server side as well as a client side bridge rather than just the client side component.
So Shiraj, I think we talked about this a little bit before the podcast. I asked the question about, is it easier to patch Flash than it is to fix a standard? Because how long has it taken, Microsoft and Google and all the other stakeholders in the HTML5 standard to agree on fixing something that could be broken? I mean, it seems to me that a company like, Adobe in this case, I guess they manage the Flash, application. It's easier for Adobe to go in and go, oh, we got to fix this because it's a bug, instead of waiting around several years to fix, say, a broken API or to implement a new feature. Does that make Adobe more flexible and more able to work, and I'm sorry, to be faster and to be more agile when it comes to implementing new technologies?
In a way, we can say that it's like a one bundle which you need to update. And as far as the standards are concerned, maybe you need to bring everyone on a same page if you want to make some changes in the standard itself. But pretty much what have happened is like some of these standards are already way mature. Like as 2-3 years passes, as you can see, any vulnerabilities or anything which is coming up which get fixed. And more or less, if you look at the problems in the past where vulnerabilities are discovered in HTML5 or so on, they are more towards the implementation of the standards rather than the standards itself. So say, for example, the implementation problem with the WebSocket or implementation problem with any other standard into a particular browser like a Chrome. So Chrome has to fix things and pass on and so on. So in a way, you can say that something is find vulnerable, Flash can be fixed by Adobe, or in the similar way, if something found vulnerable in a standard, then standard has to be fixed. Whether it's more agile or not, it's definitely, I think, standards. Fixing a standard would be some kind of exercise, I would say.
Sriraj, what is your favorite type of HTML5 attack? I mean, we have a list in the show notes, SQL injection, cross-site scripting, all the old stuff still applies to HTML5. Have you seen anything that's really cool or developed anything yourself that's pretty awesome from an attacker perspective?
Definitely, like one of the area is definitely a DOM-based cross-site scripting. So pretty much DOM-driven XSS, which is the streams coming from various things and getting loaded dynamically on HTML5 DOM, where you can perform some good DOM-based cross-site scripting. Another is a CSRF. So as you like, if a course policy where you can create a CSRF attack using XHR itself. So it's a very silent attack. So in XHR, if the header is going with the text HTML and a browser server is supporting it, then pretty much you can go ahead and perform CSRF. So I think lot of different web-based attacks from the XSS and HTML point of view, like a CSRF or XSS. There is a lot of powerful things can happen there. Another one is definitely a lot of different juicy information which is stored in a local storage. So when the information is right in a local storage, and you get an XSS on that particular application, then you can scrub this local storage information as such. So that is another interesting area. Apart from there, a lot of different attacks, the crypto kind of attacks, where a lot of things which are already stored in a JavaScript from HTML5 page. So you can reverse engineer the implementation and try to see whether you can tamper with certain variables and so on. So there are definitely a lot of interesting things which you can look around. But one of the most important thing is, like, what have happened is, with this particular architecture changes, applications are becoming very thick from a JavaScript standpoint. So like, we had a thick client, and then we moved to a thin client, that is a browser, and now we are again into a thick client, because every page would be like a single page application. So when you go to the page, page will ship you, say when you hit the slash, they will pass you a lot of JS libraries, and they get all loaded on a one shot, and now you are sitting on the one DOM all the time, and playing around with the application. So there are no refresh and reload which we used to have in a traditional application. These all applications like more like a single page application. So so then now you have like a model view and controller architecture, where you can do a lot of tampering on ingoing and outgoing streams as well. So from that standpoint, there are a lot of different cool things can be done. But now I would not say that all these cool things are due to HTML5, but it is more like a HTML5 based architecture or implementation, where now you have a JSON streams going from a little widget sitting in HTML5, which you can tamper and so on.
So with HTML5 coming out, you would think that they would have at least solved the OWASP top 10, or at least, put in things that would help mitigate that. But you said that there's still cross-site scripting. There's still
no way,
CSRF.
no, yeah. So pretty much like no way the OWASP top 10 can be fixed by HTML5. Like HTML5 will have their own OWASP top 10, I would say. So you have XSS in a traditional application, you will have definitely XSS in your HTML5 application, and the way it is implemented, you have many more opportunities for HTML5 in HTML5 for cross-site script injection or so on, be having a DOM-based vulnerabilities and so on. So if we look at the CSRF, then or clickjacking, then there is definitely a more information or more issues with HTML5 as well. So they are not going to stop OWASP top 10, or they are not going to mitigate OWASP top 10 as such. So it's all again boils down to the secure development, like we have a traditionally used to do the secure development, be it a client side or a server side. This is right. This is the same. So there won't be HTML5 by itself is not going to help in mitigating anything. It's all up to developers who develop the application to code it in a way it's more secure.
So, but my point is, they could have made things like same origin policy and content security policy the default, and then let people decide whether or not they want to disable CSP or those kinds of things. Why didn't they make the security mitigations the default instead of making people put those in and further not changing anything? The more things change, more things stay the same, right?
Yeah, so I think it's again where the feature wins over security, I would say. So if everything is by default off or default deny, then I think the feature creation for developers would be difficult. So it's up to the content security policy, where a lot of different cool things, even a lot of different tags were added. If you look at the HTML5 security cheat sheet, where you have HTTP headers, which are enhanced for security, like X-frame option or XXX protection option, strict transport, content security policy, or origin tag, which is added, which adds on extra support for XHR-driven CSRF or so on. But some of them are definitely by default, but content security policy is not there by default, and so on. So I think, again, it's more like HTML5 is more like a standard, and it's up to the developers and the companies how they want to adopt, rather than making like a secure browser, I would say.
Well, that kind of seems to run counter to what Microsoft is trying to do with Windows 10, because if you're a home user of Windows 10, they're forcing you to do updates without necessarily, opting in. You have to pretty much opt out of software patches. Why couldn't they do the same thing with their browser, where they've turned up the security requirements on it? And I know that they did this in some instances, and then you have to turn it off basically by manually going in and doing that. It just seems like it just seems like that nothing is going to change, and we're going to have the same problems that we've always had. And it's not saving us. All they've done is add some pretty and not given us the same old protections to. And then they've added additional ones like WebSockets. You mentioned privacy issues with geolocation, the local database instances. I'd like to talk about some of those when you're done with the point I tried to make there.
Yeah. So, like, say, for example, if the content security policy, and if we do we want to provide a cross-site scripting protection by content security policy, and then we do a self script SRC, for example, where we are saying that the scripting attack cannot be loaded by default. Then what is going to happen is, if a developer wants to load its own script by a script tag, those will not get loaded as well. So by default, deny default may not solve the problem, because it's more like the OS level stuff is a very different, because it's like a one-shot problem. Here it's like application to application. You have a different requirements, and you need to fix or you need to code, or you need to have a features based on application to application. So by default, the deny all may not work in the sense where we have like multiple applications and multi-people applications working around. So